Hello, everybody, and let me just move that a little bit. Welcome to another science class. Tomorrow, remember, is our live meetup. We will be meeting at your regular class period time for about 20 minutes, and get a chance to see each other, talk to each other, and answer any questions you have, whether they're school related, non-school related, content related, whatever you want. So that'll be our opportunity tomorrow. All right, let's get right in it to what we talked about yesterday. Yesterday we were talking about, okay, so these are our ribosomes in the cell. We know their job is to make proteins. But what if somewhere there needs a protein made for repairing, building, or growing, anything like that? How does this ribosome know what protein to make? It can make all kinds of proteins. Which one do you want? That message comes from the nucleus. And so how does it get from there to there? And that's what we talked about yesterday. So let's go through that quickly. First of all, that message is going to be sent on mRNA or messenger RNA. It's very similar to DNA, but it's not deoxyribonucleic acid. It's a ribonucleic acid. And some differences there. It is a single helix. Now, I've straightened this out, okay, but it is still twisted. Let me see if I can get my black back out. In real life, the mRNA is still like twisted like this, and those amino acids come off of it, and they're actually twisted, so some go this way and some go that way because it's twisted, but it's a single helix, not a double. And what I did yesterday is we just straightened it out so we can see it better. Okay, but it is twisted. Now, there's one other difference with the mRNA, and that's how they line up. So to make this message for a protein, what happens is the DNA, this is DNA, the DNA opens up. It's kind of like a zipper. An amino acid comes and opens it up. And that exposes these nucleotides, amino acids in the center, the A's, the T's, the G's, and the C's. Okay? And what we did yesterday is we talked about once that's opened up, a piece of mRNA will form that is matched with these nucleotides here. That is called transcription. The only thing different, remember, was there is no T, there's no thymine on the mRNA. It is replaced with uracil. So instead of apples and trees, we have apples and unicorns. Remember, we call this the magical mRNA. So that U is our unicorn, our magical unicorn. The C and G still pair up. They still, what they call, code for each other. The code, the mRNA code for C is a G. Now there's a T here. Now you can see a T here because this is on the DNA, the original DNA. There is an adenine. So T, we can put an adenine here. There is adenine on the mRNA. G, you would code a C. T, an A. C, a G. Now, if there's an A here, an adenine, you might be thinking, well, it should be a T here. But remember, there is no T. There is no thymine. There is only uracil. It's a replacement on the mRNA. So A goes with U. This here, this message goes out to the ribosome. It leaves the nucleus through the nuclear membrane, goes out through the cytoplasm, and heads towards the ribosome. And we drew that yesterday right there. There's our little mRNA heading out to the ribosome. Now what we're going to do today is we're going to talk about the beginning part of what is going on inside that ribosome. We're going to look to see what's in there, what the structures look like, and what the names of these structures are. Then we'll discuss this tomorrow, review all this, and if we have time, which I don't think we will, but on Thursday we'll talk about how these get matched up. So let's go ahead. I prepared this slide coming up, so I did not have to draw anything live because, well, you know why. That's, look at that. Just so fantastic. It only took me about an hour. Make sure I'm still recording here. Okay. So what do we have here? We have a ribosome. That's this structure here. Okay. Here's our mRNA. This is what was made in the nucleus. This was part of the copied on that DNA when it split. And this sort of slid in, kind of like a spaceship, coming right into, docking into a larger spaceship, like we see in the movies. And it slides right in. Okay. This is my message that says, make this protein, what this stands for. Okay. Now, this doesn't mean anything yet to the ribosome. It has to do translation or translate what it means. And what I mean by that is these are grouped in threes, okay? And that's called a codon. So the message comes in and the nucleotides are grouped in three. Okay, so A, C, G. On the original DNA, this must have been a T, a G, and a C. And that made a codon that coded for this. All right. Waiting inside the ribosome are tRNA, and tRNA stand for transfer RNA. So they're going to be, their job is to transfer. What are they transferring? These amino acids right here. These little colorful little guys right here. These are what get attached together to make the protein. Because if you recall, a protein is a string of amino acids. That's what they are. Well, here's how we get the string of amino acids. Each one of these, this structure here is a tRNA. It has on the bottom an anticodon. This anticodon will match up with one of these. Okay, so let's see which one matches up with what, and I'll try to do the colors. So AUG, we got to look for one down here that would match up with. So I'm looking for one. The opposite of A is U because there is no T. So I'm looking for a codon that has U. Now this is a U that matches up with an A. So U, A, C. There it is, UAC. So I'm going to take this to blue. This one is going to come down. And it's going to go right there. That whole structure is going to come down and connect on. The reason it can connect on is it has the correct anticodon for this one. If this one came down and tried to go here, A does not go with A. U does not go with C. G does not go with G. It could not connect. It's like a lock and a key. The only one here that this could go down to, it would come on. If it tried this one, it wouldn't fit, and it would be able to come down here. All right. So what happens then, once this comes down here, it will drop off that amino acid here, and the tRNA will go back empty. I'm going to try to draw this one. It'll go back without this on it. It drops it off here. And each one of these is going to come down, find its correct match, and drop off the amino acid here. They will all bond together. Whoa. They will all bond together to make the protein. They'll make what's called a peptide bond right here. So let's see where this one goes, this light blue one. The anticodon on this tRNA, the whole thing is called a tRNA. The anticodon is AAU. Okay, A, that codes for uracil, U. Apples are eaten by unicorns. So I'm looking for U, U, A. And there it is. So this one is going to come down here. Let's see where this one's going. All right. It is the anticodon. Anticodon is UGC. So the codon it's going to look for down here is U goes with A, C, G. A, C, G. The opposite. And where is it? Is there one down here? There is not. So this one is not going to be used. There is no A, C, G. All right, let's look at this one. U, AC is the anticodon, and it's going to code for AUG. AUG. There it is. That one's going to go this way. All right, let's take a look at the orange one here. I only color coded these, they don't have colors. They're just different amino acids. Chemically, they're different. We use colors here. This is GCG, so we're looking for CGC. There it is. CGC. All right. And now CGU is the anticodon. So we're looking for GCA. And there it is. And that is the purple one. All right, now this one here does not have a tRNA matchup here. So let's make one. Let's get rid of... We'll get rid of this. And we'll make an anticodon here. All right, so this one doesn't have his match. So let's draw the lines. Let's see here. Now you can see why this took me a while. So we're going to draw the T, not in black, not there. We're going to draw the tRNA, the structure. Yeah, I know, it's terrible. Doing it on the fly, people. Okay. And we need a amino acid on top. And we need to give it a color. We haven't used green yet. We'll make it green. We'll try to make it green. That's close enough. Okay, now we need to make the anticodon for this one here. This is ACG. So what must the anticodon be if we want that to match up? A codes for U, C codes for G, and G codes for C. This one will now match up with that one. U, A, G, C, C, G. This one will go there. And what you'd end up with is, after they drop off their amino acids, you're just going to have a line of amino acids here that'll get bonded together. Those line of amino acids is a protein. And then that gets shipped out this way. The mRNA comes in this way. And then the mRNA goes out along with the protein that it created. All right, so let's take a look at some of the notes that go along with this. If we can here. And this whole thing is called protein synthesis, the making of proteins. right? The mRNA, that's the messenger RNA. The tRNA is that transfer RNA. That's this guy right here. This whole structure is called the tRNA, the transfer RNA. Yesterday, we learned about transcription. That's what we do here inside the nucleus. The DNA is transcribed onto mRNA. That's what we did yesterday right here. AUTA. We're creating that mRNA through transcription. Translation is what happens, what we discussed today. This is translation with the tRNA is being translated based on the mRNA. That's called translation. They're two words that sound very similar. Think of transcription. This is what happens in the nucleus. Transcription is when you make the mRNA. Translation is when the tRNA make the protein inside the nucleus. The codon is this right here, the group of 3 nucleotides on the mRNA. They're groups of 3. That's a codon. And the anticodon is the group of 3, right here, nucleotides on the bottom of the tRNA. The anticodon matches up with the codon. Okay? AU, AU, UA. All right? And I have a drawing on here also. And I didn't have color, but what I used was different shading there. And you can see here, here's a long string of mRNA going all the way across. And then the correct tRNA that came down. So for the UGA, the one that came down was let's see if we can, the correct one that came down was a ACU anticodon. Okay, for the codon GCA, the correct tRNA that came down was a CGU. Remember, this is uracil because there's still no thymine. The only place you'll find the T is on the DNA. For this part of the mRNA, its codon was AUG, its anticodon UAC. All right, so here's an example here. The whole structure, remember, and here's one coming back. It had dropped off its amino acid, and it's on its way back up into the ribosome to pick up another one. So if they're coming back, if they don't have an amino acid, that means it's like a car that dropped their kids off at school, and they're going back home to pick up another kid to drop off to another school. So they've already dropped off their payload here, and they're going back up into the ribosome to get another one. Right? And then the chain of amino acids right here. This is the protein. This might be a protein to fix a cut on your skin, to make your fingernails grow more, to tell the tendons to increase production you're growing. Okay, that's what's coming out this side of the DNA. So before we go, let's take a real quick. Here is a codon. This is on the mRNA right here. This is the mRNA. mRNA. If the code for this was GCU, okay, that's the codon. What would the anticodon be for this? And we'll just put a dot up here for the amino acid. I'm trying to make a dot. It's turning into a mess. All right. Here's our tRNA. tRNA. All right. Now we're looking for the correct codon here, down here. If this is a G, GCU, running into some technical difficulties here. All right, GCU. What would be up here? Hopefully you're thinking it would be CGA. That would be the correct anticodon here to make this one match up with that one. And they do that for all of the codons on the mRNA until it's complete. Okay, there is a video for this on our website here. I believe. Here it is, protein synthesis. Great video, which will give you even a better understanding of what we talked about here. Just a little side note as we wrap this up, the participation for these videos in this online sort of e-learning, distance learning, I think a lot of teachers have seen that it's dropping off. For those of you that are tuning in and watching the videos and learning and taking notes, it's a good idea to make your own notes based on this. I just want to say, well done. I'm proud of you for continuing your education, to keep learning. I keep track every day of how many views videos get and who are submitting and who isn't. And just so you know, we are giving the, not names, but we are giving our administration numbers. I put out 82 assignments and I got 40 back, 30 back, 50 back. And they're keeping track of just the percentage of people that are participating. And so for those of you that are doing what you should do, good on you. And keep it up because you're doing the right thing. Okay, everybody. See you tomorrow in the live meetup.